All right, hi there, guys. I'm back. My name is Wilfrid, and I'm a senior math tutor. So today I'll be covering 9 questions. Some of them are from pre-calc, and some of them are calculus questions. A little backstory on myself: I graduated from a master with a major in biochemistry and a minor in mathematics. And these questions that I'm solving were submitted through OneClass. So if any other problems with your homework or any questions, please submit them through OneClass and we'll try to get through them as a senior math tutor team. So let's start on the first question. Okay, cool. So the first question reads, how do you expand x minus 1 cubed? So let's start by writing out what x minus 1 cubed is equivalent to. So x minus 1 cubed can also be written as x minus 1 times x minus 1 times x minus 1. Okay, so we're going to need to expand each of these factors. And so we're going to expand these first two factors first, okay? So we're going to use our FOIL method, which means that we're going to multiply the first terms together, add them to the outside terms, the product of the outside terms, the product of the inside terms, and the product of the last terms, okay? So the product of the first terms is as follows. So it's x squared. The product of the outside terms, which is x and negative 1, is negative x. The product of the inside terms is negative 1 times x, negative x. And the product of the last term is negative 1 times negative 1, which is positive 1. Okay, we'll leave the other factor here for now. We're going to simplify this first bracket, which is going to be x squared minus 2x plus 1. And we have not expanded it fully yet. We still have this factor. So we're going to multiply each term in this first bracket with the other terms in the second bracket. So let's do that. X squared times x is x cubed. X squared times negative 1 is negative x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is positive 2x. 1 times x is x. And 1 times negative 1 is negative 1. Okay, so we're going to simplify this, which is x cubed minus 3x squared plus 3x minus 1. And now we have fully expanded x minus 1 cubed. So the junior tutor also provided the solution. So they expanded the first two terms together to get our first factor, and then they used this to expand it into the other x minus 1 to produce the final answer, which is x cubed minus 3x squared plus 3x minus 1. So this solution is correct. Good job. Cool. All right, so let's move on to the second question. All right, so the question reads, if y varies inversely to x and y equals 18 when x equals 4, find y when x equals 16. So when the question says that y varies inversely to x, that means that y is proportional to x at a certain, I guess, with a certain relationship, okay? So how we write that is when it says varies to x, we write this proportional signal. So this signal in the middle means that y is related to x in some manner. This by itself means that y is positively proportional to x. So when y increases, x also increases. When x increases, y also increases. There's also this negative proportion, which means that, sorry, not the negative proportion. And then there's the other proportion, which is the inverse proportion, which means that as y gets bigger, x gets smaller. And when x gets smaller, y gets bigger. Okay, so when the question says y varies inversely to x, we know that y is inversely proportional to 1 over x, okay, or proportional to 1 over x. And not only is y proportional to 1 over x, we have to consider the fact that there might be a constant involved. So there might be a constant k that's related to y and 1 over x. So then the relationship would actually be y equals k times 1 over x. So we can't just assume that is 1-to-1 proportional relation. We have to consider that there might be a constant k. So it might be related to 2-to-1 or 3-to-1, right? So now the question is asking us to figure out the relation between y and x, okay? So we have this general formula here, and we're given two data points. We're given when y is equal to 18, x is equal to 4. And they're asking us to find what y is when x equals to 16. So since we're given this first initial data point, so when x equals 4, y equals 18, we can plug it into our general equation, okay? So we have our general equation here, and we're going to plug in y equals 18, and we're also going to plug in x equals 4, which is going to give us this, and we can solve for k. And k in this case, if we multiply both sides by 4 to get rid of this 1 over 4 here. 4 times 18, which is 72. Okay. And I think I wrote the question wrong here. This is supposed to be 8, not an 18. Now I'm looking at it. Sorry about that. So actually, this is supposed to be just 8. Okay. So actually, this is erase that. This should be a 32. Okay. So now we have found our constant k. So now we know that y is related to equals 32 over x. Okay. So now that we have this equation, we can plug in x equals 16. So plug in x equals 16. And we get y equals 32 over 16, which equals 2. So therefore, when x equals 16, y equals 2. Okay? So that's the exact answer that the junior tutor got. So this solution is correct. Okay. All right, moving along to question number 3. All right, so the question reads, how do you find the length and width of a rectangle given the perimeter of 180? Okay. So let's write out our relevant equations first. Okay. So we have the perimeter of a rectangle. So a perimeter, and that equals 2 times the width. So let's say W for width plus 2 times the length. Okay. So that is our perimeter equation. Our area can be calculated as the width times the length. Okay. So we're given the perimeter of the rectangle, which is 180. So we need to find the width and the length from that. Okay. So let's plug in 180 first. So 180 equals 2W plus 2L. All right. So if we want to isolate for, let's say, the length, we can say that L equals 90 minus W. Okay. So now we're going to plug this this equation. I guess we're going to call this 1. So plug 1 into area equation. Okay. So we plug it in. We get, so our area for A equals W times 90 minus W. And if we expand, we get negative W squared plus 90W. So an interesting thing here is as we're trying to find the length and width of the rectangle, we notice that the length and the width of the rectangle can vary based on the area of the rectangle. And that kind of makes sense to us because without a set area, the width and the length can be variable in that case, right? We can have a very, let's just do an example here. So let's say that we can have our width be, I don't know, 1, and our length be 89, okay? So that means that we have a very skinny rectangle like this, right? So that can be a case here, right? We can also have a width equal to be 45 and the length equal 45, right? And that will be a square, right? So our rectangle can vary based on the area, right? So the question is kind of misleading because they don't really give us the area, which is the other piece of information that we need to solve the length and the width of a rectangle. So the junior tutor in this solution, they assume that the area is the maximal area, okay? And we can see here that the area of the rectangle is actually related quadratically to the width of the rectangle. And so to maximize our area, we have to find the vertex of our rectangle, okay? If you guys can't see that, area equals negative w squared plus 90w. If you draw that out in a quadratic, if you graph that out here, since the coefficient a is negative, we have a downward facing, parabola like this, right? So we now know that the area is related to quadratically to the width of the rectangle, and the junior tutor assumed that the rectangle is at its maximal area, which means its vertex. So to find the vertex of the quadratic formula, we can do that visually, or we can use this equation. So the x value of the vertex equals negative b over 2a. Okay, and if x vertex equals negative b over 2a, we get 90, negative 90, which is the b, divided by negative 2, which equals 45. So the x vertex is 45, and that means the y vertex, if we plug it back in, or I guess the area, would be 45 squared plus 90 times 45. And that would equal 45. Okay, so we would also plug this 45 into this equation to find our length. But now we have figured out if the area is maximal, so the area is maxed out at the vertex, that means the length and the width equals 45. Is there units here? I don't think so. And the width is 45. So that will change if the area is different, but this is how you calculate it. So the area was 89, then the width and the length would be 89 and the width would be 1, right? So yeah, so that's how you solve this question. Unfortunately, the student that posted this question didn't give us an area, so we just assumed that the area was max. It was at the max. The solution is correct given the assumption that the rectangle has is the rectangle's area is maximum. Cool. All right, let's move on to question number 4. All right, so find the point on the line y equals 5x plus 4 that is closest to the origin. So if you guys are unaware, the origin is 0, 0, or the center of the graph. Let me just draw this out, and we can try to solve this visually, okay? So we know the y-intercept, if we plug in x equals 0, is 4. So let's say 4 is here. And let's plug in one more point. So if x equals 1, y equals 9. So let's say 9 is here. So we have 2 points here and here. And this is our line. It's pretty steep. Okay, this is our line. And we're going to write y equals 5x plus 4. Okay, so we're looking for the point on this line that is closest to the origin. Okay, so the origin is here. So this point right here would be the line that's closest, or the point that's closest to origin. Okay, but how do we find that point? Well, if we were to take a line that is perpendicular to this line, so let's try to draw a perpendicular line. Let's try to draw a perpendicular. Let me use a different color too. Let's try to draw a perpendicular line. It's really small, sorry guys. Okay, let's say that this line is perpendicular. It's not even straight, but let's say this line is perpendicular. And let's show that it's perpendicular by drawing a right angle here. So if we were to find a line that's perpendicular and that goes up to our original line and goes to the origin and goes to that point, we can find our point that's closest to the origin of original line by finding the point of intersection between these two lines. Okay. So that's how we're going to solve this question here. And this is what the junior tutor also proposed. So first of all, we need to talk about a fact about perpendicular lines and the line equation, okay? So there's one main fact is that to find a line that is perpendicular to our original line, we can use the fact that the line perpendicular to, let's use our general form y equals mx plus b has the slope m of negative 1 over m. Okay, let's say that this is slope n actually. So this is a fact that we need to use to solve this question. So any line perpendicular to our general line y equals mx plus. Okay, sorry about that. I had some internet issues. So the perpendicular line is going to be of the equation y equals negative 1 over 5x. Okay, so the final piece of the puzzle, let me scroll down and move up a bit, is to set these two lines to be equal to each other to find our point of intersection. So let's name this 2, and let's name this, I guess, 1 over here. So plug 2 into 1. Okay, so we plug 2 into 1, we got negative 1 over 5x equals 5x plus 4. Okay, so we're going to solve for x, which is 24 over 5 over, sorry, no, 24 over 5 x equals 4. Let me think about that. 25, yeah. And then we isolate 4x, so then we move this to the other side, so we get 20 over 24 or 5 over 6. So x equals 5 over 6. So therefore, and then if we plug this 5 over 6 back into our original equation here, so plug 5 over 6 into 1, we get y equals 25 over 6 plus 4, which equals 24 over 6, which equals 49 over 6. Okay. Let me just check if my math is correct here. Move this over to the other side. Oh, this should be negative. So this should be 26 over 5. My bad. Sorry about that. This should be negative, so this should be this should be 26 over negative 26 over 5x, and this should equal negative 20 over 26. So therefore, this should be negative 10 over 13. Okay, sorry about that. So now we plug negative 10 over 13 into 1. I'm running out of space. So our 1 is y equals 5x plus 4. So we have negative 50 over 13 plus 4. And this is going to be a really messy number here. So 13 times 4 is like 52. So negative 50 over 13 plus 52 over 13 equals 2 over 13. So finally, we now know, therefore, our point closest to 0, 0 is negative 10, 13, and 2, 13. All right, so that was a very long question where we would try to find the line that's perpendicular to our original line. And by doing that, this line that's perpendicular that goes to the origin can be used to find the point of intersection between these two lines. And by finding the point of intersection, we have found our point on our original line that's closest to the origin. And our answers are both correct, and hopefully my math is finally correct. So this solution is correct. Cool. All right, let's move along. All right, so the next question reads, what is the product of negative root 26, or root negative 26 and root negative 13? Okay, so the junior tutor provided us some properties of square roots. The first one is that we have to remember that root a times root b can also be written as root a times b, where a and b are greater than 0. So the second property that they wrote here is that root of negative a can be also written as I times root a, because I equals negative root negative 1. Okay, so using these two properties, we can find the product of these the square roots of negative numbers. Okay, so let's write out our original equation here. So this can be written out as I times 26 times I times 13. Just put brackets around this. Okay, we can take out these i's, so I squared is I 26. I'm also going to move in the 26 and 13 in together. The other property about I is that I squared equals negative 1. So I squared equals negative 1. So this just equals 26 times 13. So the factors of 26 are 13 and 2. So we're going to break it down into such. All right. So this can alternatively be written as 2 times 13 squared, or negative 2 times 13 squared. And the square root of a square is just the number itself. So now we have 13 negative times root 2. So that's the answer to this product. We used some imaginary numbers to factor out the negative numbers, and then we broke down our numbers to find a prime number that's non-factorable, and it turned out that we also had 13 squares, so we can just remove that from the square roots, and this is what we got. So this solution is correct. Good job. All right. So moving on to question number 6. So we're going to take a course change here, and we're going to start talking about derivatives and everything. So the question reads, how do you find an equation of the tangent and normal line to the curve y equals root 2x plus 3 at the point x equals 3? So we need to find the equation of the tangent line at the point x equals 3 of this curve. And to do that, we're going to need to find the slope, and we're also going to need to find the y-intercept of that line. Okay. So to find the tangent, what we can do is we can derive this curve, and we can find its derivative. And by doing that, we can plug in x equals 3, and we know that the slope of the tangent line is equivalent to the the value of the derivative function at point x equals 3, okay? So first of all, let's calculate the y value of the curve at x equals 3, okay? So let's write down the original equation here, 2x plus 3. So let's plug in point x equals 3, okay? X equals 3 and y equals 3 times 2 is 6 plus 3, and that equals root of 9, which equals 3. So now we know that we need to find the tangent line at 3, 3 of curve y equals root 2x plus 3. Okay? So now we're going to differentiate this curve, and we're going to calculate the slope at x equals 3, okay? So we know that y can be written out as the square root can be written out as 1 over 2. So y prime, we're going to use our chain rule here. So we're going to move down this 1 over 2 first, 2x plus 3. 1 over 2 minus 1 is negative 1 over 2. And we're going to differentiate the inside, which is just 2. These two cancel out, so we're left with 2x plus 3 to the power of negative 1 over half. And so the power of negative 1 over half is just, in fact, 2x plus 3, the square root of, so 1 over the square root of 2x plus 3. So now we're going to plug in y of 3 into this. So that'll be 1 over the square root of 2 times 3 is 6, the square root of 9. 6 plus 3, 9. So that'll be equals to 1 over 3. So now we found our slope of our tangent line. So m equals 1 over 3. And all that's left for us to find is the y-intercept. So let's move down a bit. Okay, so we know that now our tangent line equation is y equals 1 over 3 x plus b. We know that 3x equals 3 and y equals 3 is a point of this line, so we're going to plug that in. So plug in 3, 3, which equals 3 equals 1 plus b, and we now know that b, or the y-intercept, equals 2. So now we have found our line equation, which is y equals 1 over 3 x plus 2. Okay, cool. So that's the first part of the question. We have found our tangent line to the curve. So now they want our normal line to the curve, okay? So the normal line to the curve will be the line that's perpendicular to our tangent line at 3 of 3. So like our last question, all we really need to do to find this is to take our slope and do the negative reciprocal of the slope, okay? So we're going to do normal line slope is a negative reciprocal of this slope, which is, so if we do a negative reciprocal, we're going to flip this and put a negative sign in front of it. So 1 over 3 flipped is 3, negative 3. Okay, so the equation equals y negative 3 x plus b. And we plug in 3 of 3, and we get 3, negative 9, 12. B equals 12. So therefore, normal line is y equals negative 3x plus 12. And our tangent line is y equals 1 over 3x plus 2. So let's check the answer here. So the answer is correct. And they found the tangent line by first finding the point on the curve, which is 3 and 3 over here. They derived it, and by deriving it, they can now find the slope at x equals 3 by plugging in y of 3. They did that, and they found that the slope is 1 over 3. They then used the slope-intercept form to derive their line equation. So they didn't solve for a y-intercept per se, but they used a slope-intercept form to find the line equation for the tangent line. They realized that the slope of the normal line at 3 of 3 is going to be the negative reciprocal of the slope of the tangent line. So that would be equal to -3. They plugged it in using the slope-intercept form to find the line equation of the normal line, and they stated their line equations here. Okay, so the solution is correct. Good one. Cool. All right, moving along. So the next question reads, for what values of x does a graph f of x equals x cubed plus 3x squared plus x plus 3 have a horizontal tangent? So another word for horizontal tangent, so a fact is that the slope at this point equals 0. Another way of saying that is the rate of change at this point equals 0. So when they're asking us to find the horizontal tangents of the graph, they're asking us to find the points on the graph where the slope or the rate of change is 0. So to do that, we have to use our derivative, and we're going to need to calculate at which points of the derivative is the f of prime of x equals 0. Okay? So let's write out our original function first here. So f of x equals x cubed plus 3x squared plus x plus 3. Okay, so f prime of x equals, so using our power rule, we move the 3 down and minus 1 on the exponent, 3x squared plus 6x plus 1. Constants that are differentiated are 0. So this is our differentiated function, and we're going to need to find when f prime of x equals 0, what are the values of x. Okay, cool. So we can normally use factoring for this if you guys recognize this is a quadratic function. But since it's not easily factorable, we're going to use the quadratic formula. So the quadratic formula states x equals negative b plus or minus b plus or minus b squared minus 4ac divided by 2a. Okay, cool. So solving for this equation will give us the values of x where f prime of x will equal 0. Okay, so we're going to plug in our coefficients. So negative b is -6 plus or minus the square root of 6 squared minus 4 times a, which is 3, times 1, which is 4 times 3, divided by 2a, which is 2 times 3, which is 6. Okay, so -6 plus or minus 36 minus 12 is the square root of 24. 36 minus 12, 24. Okay, divided by 6. And we can get rid of the 6, which is just -1 plus or minus square root of 24 can be written as 4 to, oh wait, we can't factor out the 6 yet. Let's just write this for now, plus or minus 4, 6, yep, divided by 6. So this can be written as -1 plus or minus 1 over 3 times root 6. Okay, so this can alternatively, I'm going to write the form that the junior tutor wrote here. So we're going to factor out 2 instead. So this can be alternately written out as -3 plus or minus 6. Oh, 6. So this and this are equivalent. So these are the values of x that will make f prime of x equals 0. So in that case, on the original graph, the x equals -3 plus or minus √6 are the points on the original graph where there's a horizontal tangent, or in this case where the slope of the point is 0, or the rate of change at that point is 0. So this is what the junior tutor wrote. So they found the derivative of our function. They used a quadratic formula to find our x's that make this f prime of x equals 0, and then they concluded that these points will also be related to the original function, where at these points of x, there will be a horizontal tangent on the original function. Okay, the solution is correct. Good work. Cool. All right, moving on to question number 8. All right, so the question reads, determine when whether the function f of x equals x times the absolute value of x is odd, even, or neither. So when a function is even, if f of x is even, then this is the, I guess, the condition that follows. So f of x is even, then f of negative x is equivalent to f of x. Okay? If f of x is odd, then f of negative x is equal to negative f of x, okay? So these are the two properties, right? So this question is basically asking us to evaluate whether the function is even. So whether when f of negative x equals f of x, when it's odd, when f of negative x equals negative f of x. So the function is neither if either of these do not occur. Okay, so let's try to evaluate this now. So let's write down our original equation here, our function here. F of x equals x times the absolute value of x. Okay, so let's say we have f of negative x. What would that be? Okay, so f of negative x would be negative x times the absolute value of negative x. So the way that absolute values work is that absolute value of negative x is also equivalent to the absolute value of x. So therefore, we have f of negative x equal negative x times the absolute value of x. And here we can just sub out the negative, and this is equivalent to saying negative f of x. So now, therefore, f of x is odd. Okay. If this were to equal x of absolute value x, then it'll be even. And if it were to neither be negative f of x or f of x, then the function is not odd or even. So the junior tutor provided the same solution. They stated what an even function and an odd function is, and then they evaluated f of x equals x of absolute value x, and they came to the same conclusion that f of x equals negative f of x, which means the given function is odd. Cool. Finally, let's move on to our last question of the day. So the question reads, evaluate each expression. So they have 6 expressions here. So we're going to evaluate each of them, okay? So we have A, which is -3 of 4. What is that equal to? So that is equivalent to saying -3 times -3 times -3 times -3. -3 times -3 is 9. Let's do the other one. 9 times 9, that equals 81. Okay. B, -3 to the power of 4. Okay, so this one is different because using our bedmass rules, we always evaluate exponents first before we apply any negatives or positives. Okay, so this is actually in fact negative 3 times 3 times 3 times 3. That's what we have here, which is equal to negative 81. So the difference here is that in A, we specified that we want to multiply negative 3 4 times together, right? But here we are specifying that we want to multiply 3 4 times together before applying the negative. Okay. All right. So C, we have the inverse. So we have 3 to the power of negative 4, which is also equal to 1 over 3 to the power of 4. Or we could think about it as 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3, which would be 1 over 9 times 1 over 9, which is 1 over 81. Cool. D. So this is using some power or some properties of exponents here. So it reads 5 over 23 divided by 5 over 21. This could be also written as 5 over 23 times 5 over negative 21. Oops. And using our product property for exponents, we know that this is equivalent to saying this. And this is just 5 squared, which equals 25. All right, E. So 2 over 3 to the power of negative 2. That is equivalent to saying 1 over 2 over 3 squared. And that equals 1 over 4 over 9. And since the fraction is at the bottom, we have to flip it again if we wanted to flip it over, which is 9 over 4. Finally, let's do F. Okay, so F is 16 to the power of negative 3 over 4. Okay, so 16 can also be written as 4 squared times negative 3 over 4. If we use our product rule here, or our rule of exponents to the power of exponents, we know that this is also equivalent to saying 2 times negative 3 over 4, which would equal, actually 16 can also be written as 2 to the power of 4. My bad. What am I doing? So this can be written as 2 to the power of 4, which can also be written as 2 to the power of 4 times negative 3 over 4, which equals 2 to the power of negative 3. And we know that that equals to 1 over 2 to the power of 3, which equals 1 over 8. Okay, so that's how you evaluate all these expressions. And these are a few different tricks of how to calculate these exponents. We use a quotient rule here. We figured out that whenever we're having a fraction to the power of a negative exponent, we need to flip the fraction as we simplify it. And for F, we can figure out that 16 is actually 2 to the power of 4, and by using that property, or that fact, we can simplify this exponent to make it simpler for us to solve. So the junior tutor provided the solutions here. They didn't do the step-by-step. But for E, they forgot to flip the fraction. So this solution, so the solutions to A, B, C, D, and F are correct. The solution to E is almost correct. You forgot to flip the fraction in the last step. So flip the numerator. Let me specify more. The numerator and the denominator in the last step. Cool. So that's how you evaluate all those expressions. And unfortunately, the solution is incorrect. All right, cool. So that wraps up today's math lesson. I covered 9 questions ranging from derivatives to line equations to exponents today. If you have any problems or questions with your homework or with your mathematics, please submit them through OneClass and we'll try to get through them. But other than that, I wish you guys a good night and I hope that you guys learned something today.